Okay, let's now move on to the second portion of this chapter called investigating electricity. Okay, the first concept we want to examine is this concept called current. So you take a look at the diagram, which is called a circuit diagram, that shows the electric cell. Okay, that is the source of the energy, which has a positive and negative polarity, and there are connecting wires here to connect the wire to the light bulb. Okay, the arrow in red actually represents how the current flow to allow the light bulb to work, which is to light up. So how it works is that the current will always flow from the positive terminal, okay, which is in this diagram is in a anti-clockwise direction. Okay, so it starts to move. The current will move, which are carrying charges. It will actually move from the positive to the negative terminal of the battery. So this is the first important concept of electricity known as current. So current is actually is known as the rate of flow of charges, how fast the charges in the circuit moves, which is actually produced by the electric cell, or sometimes we call it as a battery. Okay, so let us now move on to the next concept. Okay, is there an instrument that we use in science to measure the amount of current? Because current is actually the amount of charges that move in a certain duration. So in this case, you look at the diagram, okay, which has a red and black terminal. So the red actually is a positive terminal. The black, okay, side is actually the negative terminal. So we use this instrument known as an ammeter to measure the amount of current. And when you want to measure the amount of current, you have to make sure the ammeters are connected in series. Series means that it's actually side by side with each other. Okay, so take note that an ammeter has two terminals, positive and negative. Okay, let's move on to the next slide. Okay, when we do measurement, there's always a unit. So in this case, the SI unit for electric current is ampere. Okay, the symbol is capital A. In this case, if I say that a current of 2 ampere flows through the circuit from the positive to negative terminal, this is called 2A. So we say current is 2 capital A. This is the amount of current. Okay, the next concept is voltage. So what exactly is voltage? Voltage actually provides the energy for the current to flow. So if you don't have voltage, your current is unable to flow through the circuit to make the light bulb work. Okay, so you can think of the voltage as just like a water pump. So you have the diagram on the right. So imagine the water pump is just like your dry cell or your battery. So in order for the water to flow in the water pipe, you need the water pump to pump the water. So in this case, you go back to the concept of electricity or electric circuit, you need the battery to start to push the charges or the current around the whole circuit to make the light bulb work. So in this case, we can imagine that voltage is something like the water pump that's pumping the water around the pipe. So in this case, the pipe is the electric circuit. So if you remove the water pump, the water will stop flowing. So it's the same as the electric circuit. If you remove the dry cell or the battery, the light bulb will not work because there's no current flowing through. Okay, so this is the concept about voltage. So we move on to the next one. How do we measure the amount of voltage? Okay, for example, the battery. How do we measure the amount of voltage? So we use this instrument known as a ammeter. This is a voltmeter. So voltmeter, the connection is in parallel with your light bulb or your battery. Okay, so what is the SI unit of voltage? The SI unit for voltage is volts, V-O-L-T. Okay, the symbol is capital V. So in this case, if I say the battery has a voltage of 1.5 volts, it's actually written as 1.5 capital V. Okay, let us move on to the next concept about what would be the effective or total voltage if I connect the batteries or dry cell in series, which is side by side. Okay, so if one dry cell is usually 1.5 V of voltage, if I connect two or more in series, okay, by connecting the plus minus, okay, in sequence, then I will increase the total amount of voltage. So if I got 2 batteries, the total voltage will be 3 volts. If I have 3 batteries, the total voltage will be 4.5 volts. Just take the multiples of each. Okay, and you need to connect in the correct manner, or else your circuit cannot work. Okay, we have finished learning about current and voltage. We move on to the third concept in electricity, which is known as resistance. So what is this concept about resistance in electricity? So resistance is actually something, or a concept in electricity. It talks about how we oppose the flow of current. So current is actually flowing the circuit. So resistance is the concept of something that's opposing the flow of current. So all electrical components have resistance, but different components, they have different amount of resistance. So some components might have higher resistance than others. Okay, so you look at the two objects on the right, the copper wire, because it's just a wire by itself, wires have very low resistance. Okay, but light bulbs have higher resistance than copper wire. Okay, let us move on to how resistance is related to current. Okay, you look at the circuit here, the current is actually flowing in the whole circuit. Okay, but in this case, if I put 2 batteries, the 2 batteries will create a higher resistance. So if I got higher resistance that's blocking or resisting, opposing the flow of the current will be smaller. It's just like, imagine you have rocks and stones in your water pipe. Okay, so in this case, there are too many rocks and stones that's blocking the flow of the water. So the water is like your current. So you have more rocks, which is resistance, you have less amount of water that can flow through the water pipe. Okay, so in summary, the higher the resistance, the smaller the current. Okay, so you compare with circuit B. In this case, circuit B has more current because the amount of resistance in circuit B is lower, so the number of stones or rocks is lesser, so the water can flow through easily. Okay, so circuit A, in summary, has a higher resistance than circuit B. Okay, and hence the current in circuit A is smaller than circuit B. Okay, so this is a very important concept in resistance. The higher the resistance, the lower the current. Okay, so what exactly is this concept called resistance? How do we understand it? I think just now I tried to explain that resistance is something like something that's blocking the flow of the current. Okay, so in this case, imagine you have a river, okay, on the left. So if there's nothing blocking it, the water just flows through quickly and easily. Okay, there's nothing to block it. So we call this in electricity called low resistance, nothing to obstruct or obstacles to resist the flow of water. Okay, but you look at the second diagram on the right, there's actually a tree log that's blocking the flow of the water. So in this case, the water will have to flow slower when there's something blocking it. So if there's something blocking it, it's called high resistance. Okay, so what exactly is this object called resistor, which is related to resistance in electricity? So resistor is actually an electrical component that provides the resistance. So there are actually two different types of resistors. One is called fixed resistor and one is called variable resistor. So fixed resistor means that the resistor is a fixed value. There's no way of changing it. But for a variable resistor, the resistance can be changed. You can either have a sliding contact on the bottom left. Can you see there's something on top? Actually, you can slide left or right, sliding contact to adjust the resistance. Or you have a turning knob. Okay, you turn left and right, you can adjust the amount of resistance. Okay, let's now move on to how do we measure amount of resistance. So there are actually two methods. One is you can use a multimeter. Okay, in this case, it's a digital multimeter, or you can use an analog multimeter. Okay, and the SI unit for resistance is ohm. Okay, it's represented something like a cap. And if I say this component has a resistance of 10 ohm, it's actually written as 10 ohm, which is the cap. Okay, so where do we use resistors? Okay, so resistors are actually used in a lot of electrical appliances, such as radios, televisions, and computers. So that we need a certain amount of current for it to work properly. Okay. Okay, next we move on to this concept about electric circuit. Okay, and we are going to move on to understand what is the meaning of series and parallel circuit. Okay, an electric circuit is a path for current to flow, as you can see from the diagram. Okay, so the current will flow through the circuit, okay, which has a battery or a dry cell and a light bulb. Okay, okay, what is the meaning of open circuit? Open circuit means the switch is open. Can you see on the left? The connection is not is broken at the switch. Okay, so no current can flow through. But if I close the circuit with a switch, you'll notice that the current can flow and the light bulb can light up. Okay, so current can only flow in a closed circuit. If there's an open connection, it cannot flow through. Okay, so we move on to this first concept about series circuit. So just now we did explain about series circuit. So series circuit means that the components are connected in one single path. Okay, means the current starting from the battery, the positive side, will have only one path for it to flow through. That's why it's called a series circuit. Okay, if we say that one of the light bulbs is removed or blown, the circuit will be open, and the other two bulbs will not light up. That's why it's not advisable to connect the lights in our homes in series, because if one of the light bulbs is spoiled or there's an open circuit, the other two light bulbs cannot work. Okay. So what is a series circuit? A series circuit is like a bridge with only one lane. Okay. Imagine now you are on the road. So if one part of the bridge collapses, the whole traffic flow will stop. Okay. So traffic flows on only one lane bridge. Okay. This is the meaning of series circuit. So what is a parallel circuit? In a parallel circuit, the electrical components are connected to form two or more paths. Okay, as you can see from the diagram. Okay, so the current will start flowing and it will split into the three different light bulbs. Okay, if one of the light bulbs is removed, the other two light bulbs will not be affected. That's why in our home, a lot of lights in our homes are connected in parallel. So what exactly is a parallel circuit? A parallel circuit is like a road with two separate lanes. Okay, so when one of the lanes is blocked, traffic can still pass through the other lane. Okay, that you can see on the diagram. So the left one is very smooth because the two lanes are open, but the right one there's an obstacle there, so the car can only move through the top part. Okay. Now let us move on to the different circuit symbols that I need to know of. Okay, the one on the top is called an open switch. Center top is called a closed switch. Okay, the plus and minus, the longer one is the positive, the shorter one is negative. It's called a dry cell. Okay, then the other one that has a multiple dry cell is called a battery. Okay, the one with the center cross is called a lamp. Okay, instruments to measure voltage and current. The first one is called voltmeter, capital V, circle. Okay, the one at the bottom is ammeter on the left. Okay, which is capital A. Then fixed resistor. Okay, followed by variable resistor, which has an arrow. And if I want to show that wires are connected or joined, there's a dot there. Okay, so how do we draw circuit diagrams? Okay, if there's a circuit with a cell, two bulbs connected in series and open, this is how you draw it in symbol form. Just take note that the positive terminal is longer line and the shorter one is negative, talking about the dry cell. Okay, you talk about the second diagram, the two battery cells, the two light bulbs are connected in parallel. Okay, and there's a closed switch with the battery. So you have to learn to draw circuit diagrams using circuit symbols. Okay. So we'll stop here to about series and parallel circuit and how to draw different circuit diagrams. Okay, let's now move on to the next concept called electrical hazards or hazards of using electricity. Okay, we learned that electricity, if not used properly, it can harm or even kill a person. Okay, the voltage of our mains in Singapore is 230 volts. Okay, so this is a very high voltage that's dangerous. Okay, so what are the three common electrical hazards at home? Okay, the first is called damaged insulation. Okay, which is the wiring, the rubber or the plastic has gone off. Later we'll explain. Overloaded circuits, where there's multiple plugs, and damp condition, which a certain part of the electrical appliance that you use is wet. Okay, so what are the three common ones? Okay, damaged insulation, it means that there's wear and tear, overheating of the wires. Okay, there's friction, and somehow the copper wires are exposed inside. Okay, so what happens if somebody go and touch the exposed copper wire? Okay, there will be electric shock. Okay, so what you should do is you should replace the wires with the help of an electrician and stop using the electrical appliance. Okay. Then the second one is called overloaded circuits, where there are multiple appliances plugged to the same multiple plug. Okay, too many appliances that's connected to a single main socket. So what happens is that each component or each appliance will draw its own amount of current. So current will produce a lot of heat. So overheating will cause fire. So important thing is try not to have too many appliances connected to one single socket. Okay. Okay, the last one is called damp condition. Damp condition is very common when, for example, after bathing or after using the basin, your hand is wet, and you started to touch other appliances such as can be your light switch, can be other appliances. Okay, so because your body become low resistance, it will cause electric shock. Okay, so try do not touch appliances with wet hands. Dry your hand first. Okay, or else you will get electrocuted. So what are the safety features in our home to prevent these electrical hazards from happening? Okay, so what happen is there's this thing called circuit breakers. So if it's too high a current, it will break the circuit so that current will stop flowing through. There's a second one which is called a fuse. If there's a large current that flows through, it will melt and cut off the electricity. Okay, and the third one is called earth wire. Earth wire is actually connected to the earth, to the metal casing. So in case you touch the metal casing, okay, and you will not get electric shock. Okay, let's move on to why is it important to reduce electrical energy wastage. Okay, the problem now is Singapore, we are a very small country, so we depend heavily on fossil fuels imported from other countries. And fossil fuels are limited in resources, so it will be gone forever once they are used. It cannot be renewable. And burning of fossil fuels causes pollution. So what are the ways for us to reduce wastage of electrical energy? We can use energy saving lamps instead of filament lamps. We can use natural lights and ventilation. Okay, so please take note of all these things because Singapore has limited resources. And if you are feeling a bit hot, it's good to use electrical fans. And appliances that actually ticks to show the energy efficiency, for example refrigerators and washing machine or air conditioner, try to select appliances which are energy efficient. Okay, and try to find out which are the appliances that use a lot of energy and reduce the time that they are used. Okay, so that's the last slide for the topic of investigating electricity.